This Zoom session is being brought to you by the fractal Heart of Gold forming. Well, last time was not ideal. Not only was I half asleep and late, it turns out I did 3.5 a second time, which means we have to double pace 3.6 and 3.7 today to keep up. And it'd probably be wise for me to review 3.7 after the break, because well, I like to say that holidays cast their shadows before and after. Well, here we are anyhow. So today, double angle and half angle formulas, 3.6 and 3.7, product to sum and sum to product formulas. Okay, here we start with the angle addition laws. Cosine of sum equals cos minus sine sine. Sine of sum equals sine cosine plus cosine sine. Tangent of sum is tan plus tan all over 1 minus tan tan. Now, for a double angle formula, we'll set beta equal to alpha, so that alpha plus beta equals 2 alpha. And so when we do that, cosine of 2 alpha is cos squared alpha minus sine squared alpha, like this. Sine of 2 alpha is sine cosine plus cosine sine, which makes twice sine alpha cos alpha. And tangent 2 alpha is tan plus tan over 1 minus tan tan, 2 tan alpha over 1 minus tan squared. Now, this first one, the the cosine of a double angle, we'll rephrase by using the Pythagorean identity. Cos squared plus sine squared equals 1, therefore cos squared equals 1 minus sine squared. So you could replace this cos squared by 1 minus sine squared. And then transposing the minus 1, minus sine squared equals cos squared minus 1. So we could replace the minus sine squared. So if we replace cos squared by 1 minus sine squared here, you get that cosine of 2 alpha equals 1 minus twice sine squared alpha. And if we replace this minus sine squared alpha by cos squared alpha minus 1 in here, then you get the cosine of 2 alpha equals twice cos squared alpha minus 1. So these are another version of the double angle formula for cosine. Now, this means that from here, we could solve for the square of cos alpha and of sine alpha. From here, from cos 2 alpha equals 2 cos squared minus 1, we can transpose the 1 and divide by 2 and get that cos squared alpha equals cosine 2 alpha plus 1 all over 2. From here, we could subtract 1 from both sides and divide both sides by minus 2 and get sine squared alpha equals minus cosine 2 alpha, that plus 1 all over 2. Now we could rephrase this. We could call this 2 alpha, call it theta. So alpha is theta over 2, and therefore cos squared theta over 2 equals cos alpha plus 1 over 2. Sine squared theta over 2 equals, I could rephrase that as 1 minus cos theta all over 2. And then taking square roots, we get cos of theta over 2 is plus or minus root 1 plus cos theta all over 2. And sine theta over 2 equals plus or minus root of 1 minus cos theta, that over 2. The plus or minus depends on what quadrant cosine theta over 2 is. Could be plus or could be minus, and that depends. And then dividing sine by cosine, we get then doing some arithmetic. Tan theta over 2 equals plus or minus 1 minus cosine theta over 1 plus cosine theta. Now this is probably an inaccurate attribution, so I'll have to change it. I say that we can derive from that. We can get rid of the plus or minus, and then you have a simpler formula, and get that tangent of theta over 2 equals 1 minus cosine that over sine, or sine over 1 plus cosine. I attribute that to page 244, but that's probably different in the textbook. So I may have to change that in the Canvas. That'll be it. Well, we have a couple of examples. Here we have sine of theta equals 3/5, and it's in quadrant 1. Sine double angle, sine 2 theta, cos 2 theta, and half angle, sine theta over 2, cos theta over 2. Okay, we start with theta. Its sine is 3/5. So we draw this right triangle in the plane. The opposite side is 3, the hypotenuse is 5, and by Pythagoras we can derive this. Adjacent side is 4. So if it's in quadrant 1. So sine theta equals 3/5, cos theta equals 4/5. Quadrant 1 makes these both plus. So it's easy enough to calculate. Sine of 2 theta is 2 sine theta cos theta. Well, we plug it in. 2 times 3/5 times 4/5 is 24 over 25. Cosine 2 theta. Now we could use the cos squared minus sine squared, or the 2 cos squared minus 1, or the 1 minus twice sine squared. Here I use the 1 minus twice sine squared because we were originally given sine theta. Cosine theta is just is derived. I think it's prudent always to use the freshest ingredients. So 1 minus 2 sine squared theta equals 1 minus twice the square of 3/5. After a bit of work, that's 7/25. Now, as for the half angles, well, we have to figure what angle theta over 2 is. Well, theta is in quadrant 1. Theta over 2 will also be in quadrant 1. So sine and cosine will both be positive. So sine theta over 2 is 1 minus plus root 1 minus cos theta over 2. Cos theta, that's 4/5, 1 minus 4/5 over 2. And after a bit of arithmetic, it's root 10 divided by 10. Cos theta over 2 plus root 1 plus cos theta, that over 2. That's 1 plus 4/5, that over 2. And after, again, a bit of arithmetic, that's 3 root 10 divided by 10. Here we have a half angle problem. Cosine of 165 degrees is what? So, oh dear, this needs some changing. Okay, 165 degrees is in quadrant 2. Half of that will be 80 something degrees, quadrant 1. Okay. Oh, okay, excuse me, quadrant 2. That's half of 330 degrees. Excuse me. Quadrant 165 is in quadrant 2, so therefore it's a minus for cosine. And 165 is half of 330, for which we can derive the cosine from. Cosine of a half angle is in this case a minus, because it's 65 is in quadrant 2. Minus root of 1 plus cosine 330, that over 2. Cosine 330 is almost all the way around the circle. It's 30 degrees short of a full rotation. So we get this right triangle. 1, 2, and root 3 are its sides. Cosine is root 3 over 2. So it'll be 2 halves plus root 3 halves. Okay, I think this 2 shouldn't be there. Yeah, that should not be there. Yeah, again, this is something that has to be corrected in the canvas. My apologies.
Where did the 2 on the numerator come from?
Here, a mistake.
Where it says 2 plus root 3? What the?
I'm sorry. Okay. 2 halves. There's your 1. Root 3 halves. There's your cos 330. This divide by 2 is a mistake. Apologies. And therefore, this is mistaken too. Oh dear. Gosh. I'm sorry. This is not right. This is not right. Okay, this should be gotten rid of. I think this is mistaken as well. I think that I'm going to have to change all this in the canvas. My apologies. Honk me again. All right, I'll have to review this and change it. Now here we have really this is really an angle addition problem. Prove sine 3 theta over sine theta minus cos 3 theta over cos theta equals 2. All right, we start with the left side, sine 3 theta over sine theta minus cos 3 theta over cos theta. We do what I call rabbit rule. Sine 3 theta cos theta minus sine 3 theta sine cos 3 theta, or sine theta cos theta. Okay, now sine cosine minus, well, cosine sine is an angle addition. It's going to be, oh dear, sine of 3 theta. No, it's a sine addition rule. Sine, cosine, cosine, sine. So it's sine 3 theta minus theta. The sine 2 theta cos theta would put 2 over 2 here. All right, so 2 sine theta cos theta is sine 2 theta. Sine of 3 theta minus 2 theta is sine 2 theta. And the sine 2 thetas cancel out. The 2 remains, and that equals the right side, and we're done. Okay, I'm going to have to change this. That's a serious mistake. All right, let's conclude this part.